हेलो एंड वेलकम बैक टू दिस चैनल। डियर स्टूडेंट, जैसे मैंने लास्ट वीडियो में बताया मैंने एक ऐप डेवलप किया है स्टडी मटेरियल्स से रिलेटेड। सो उसका मैं लिंक डिस्क्रिप्शन बॉक्स में प्रोवाइड करूंगा। डाउनलोड दैट ऐप, यू कैन डाउनलोड इट फ्रॉम द प्ले स्टोर, जिसमें सब्जेक्ट्स के लिए स्टडी मटेरियल आई विल बी प्रोवाइडिंग सर्टन स्टडी मटेरियल्स। So dear students, today's topic is half bridge inverters. There are two types of half bridge inverters. First is half bridge inverters using MOSFET, and second half bridge inverters using IGBT. Presently we are talking about half bridge inverters using MOSFET. From the exam point of view, you may expect the question like this: draw and explain the हाफ ब्रिज इन्वर्टर यूजिंग मॉसफेट विथ आर लोड। अब देखो उसमें भी दो टाइप्स है, एक है आर लोड और दूसरा है आर एल लोड। प्रेजेंटली आई एम टॉकिंग अबाउट आर लोड। दिस इज द करस्पॉन्डिंग सर्किट डायग्राम। हियर आई हैव शोन टू मॉसफेट्स M1 and M2. In parallel with each MOSFET, we have connected diodes D1 and D2. As far as R load, resistive load, ये जो load है, this is the resistive load. Resistive load is concerned. In this case, there is no role of diodes D1 and D2. RL के केस में, मतलब load अगर RL है, in that case, there are certain significance of the diode D1 and D2. So, as I said, we are using two MOSFETs, M1 and M2. We know the usual conventions. This is gate terminal, drain terminal, and source terminal. Same is applicable for MOSFET M2. Total available voltage is Vs, that is the DC voltage. At any time, we are applying or we are getting the voltage Vs by 2 at the output. That means half of the voltage is obtained at any time at the output. So this is called half bridge inverter. These are the corresponding waveforms. See, waveforms simple. I will explain you how to remember the things. So we will divide the intervals into two parts. जैसे देख लो, ऐसे सोचना है, total intervals is from 0 to t. So it is divided it into two parts. One is 0 to t by 2 and another is t by 2 to t. So first we'll talk about interval 0 less than t less than or equals to t by 2. I am talking about this interval 0 to t by 2. In this case, जैसे देखो, during 0 to t by 2 MOSFET M1 will be switched on. अब बेसिक चीजें याद रख लो. If any MOSFET is on, that means it will act as a short circuit. That means in place of this MOSFET, I will be connecting a simple wire. So M1 MOSFET will be on during period 0 to t by 2 and second MOSFET M2 is off. अगर MOSFET ये M2 ऑफ है, इसका मतलब इट इज शोन बाय ओपन सर्किट लाइक दिस. M2 के बदले में ये शो करेंगे, M1 के बदले में सिंपल शॉर्ट सर्किट. D1 एंड D2 आर ऑफ. D1 एंड D2, और आप जैसे मैंने बताया रेजिस्टिव लोड में देयर इज नो रोल ऑफ दिस डायोड्स D1 एंड D2. सो दिस इज द कंडीशन फॉर 0 less than t less than or equals to t by 2. Up, since M1 is on, it is replaced by a short circuit, so the current will flow. जैसे ये short circuit हो जाएगा, so the current will flow like this. So through this load, the current is from this terminal will be treated as positive to negative. That will be the voltage across V0. About the waveforms, so we are talking about 0 to t by 2. In this case, MOSFET M is on, so we are getting IM1 current like this from 0 to t by 2. This value of current is Vs upon 2R. Why Vs upon 2R? See, this MOSFET is on, second MOSFET is off, so I am talking about only this part. This is short circuited. So in simplified language, in simplified way, you can write the circuit like this. This is Vs by 2. This MOSFET is on, that means short circuited, and this is load R. So ideally, entire voltage Vs by 2 will appear across resistance R. Look at this diagram. This is IM1, waveform of IM1. This voltage is Vs upon 2R. Actual voltage, this current is Vs upon 2R. Actual voltage is Vs upon 2. We know that current is voltage upon resistance. So this value is written as Vs upon 2R. Now, this is the case when M1 is on. So this is the waveform related to IM1. Since second MOSFET is off, this current is denoted by 0 line. At the output, अभी मैंने explain किया, at the output current is flowing through this resistance are like this. So at the output you are getting voltage V0 and this is Vs by 2 because supply voltage is Vs by 2. So V from 0 to T by 2, this interval is T by 2, you are getting the voltage Vs by 2. Output current I0 is having same wave shape as that of output voltage. So this is I0 similar to that of V0. You are getting this voltage as V0 by 2 during the interval 0 to T by 2. Now very important part, जैसे मैंने बताया, the MOSFET M1 is on, that means it is replaced by a short circuit. Whenever a short circuit is there, voltage across that line is 0 and current is infinity ideally. So we are talking about the voltage. Since this M1 is on, that means it is short circuited. This voltage is 0. So across this line, I mean across voltage across M1 is 0. It is shown by this line. Whereas M2 is on, so for VM2 the waveform is like this. Sorry, M2 is off, that means it is treated as an open circuit. M2 is off, so it is treated as an open circuit. Whenever it is open circuit, entire voltage, output voltage will be appearing across this M2. So it is shown by this positive pulse. This is the case during 0 to T by 2. Now next interval, T by 2 to T. In this interval, reverse case takes place. That means initially M1 was on, now this will be off. So M1, D1 and D2 are off. Since M1 is off, it is represented by open circuit. This is open circuit. Whereas M2 is on, so it is represented by short circuit. This is the case from T by 2 to T. That means for this interval. So in this case, M2 is on, so corresponding current will be IM2 like this. जैसे मैंने ये IM1 का explain किया. Likewise, in this period T by 2 to T, this M2 will start conducting. It is on, so current IM2 will be present from T by 2 to T. So it is shown by this line. Then this M1 is off, that means it is open circuited, and M2 is on, that means it is short circuited. So in this case, the flow of current will be like this. That means this terminal will be positive, this terminal will be negative. It is opposite to that of previous case. So output voltage V0 is minus Vs by 2. Earlier in the previous case, previous interval, it was plus Vs by 2. Now look at the polarities. Polarities becomes opposite as compared to the previous case. So this is minus Vs by 2. So you are getting the voltage minus Vs by 2 during the interval T by 2 to T. So this is the corresponding waveform. जैसे मैंने VM1 और VM2 का explain किया. In this case, VM1 is off. Whenever it is off, entire voltage will appear across this, and VM2 is on, so voltage across VM2 will be 0. This is the waveform for IM1, IM2, V0, that is output voltage, output current, VM1, voltage across MOSFET M1, voltage across MOSFET M2. These are the parts, or these are the corresponding waveforms for one cycle. One cycle is from 0 to T by 2 and T by 2 to T. That means from 0 to T. Naturally, the cycle repeats and you will be getting the similar types of waveforms. So this is about the explanation and waveforms related to half bridge inverter with R load using MOSFET. If the question is same thing, half bridge inverter using IGBT, then only change is you have to replace MOSFET by IGBT, and we know that symbol of IGBT is like this. It is somewhat like a transistor. So in place of MOSFET, you need to draw IGBT. Waveforms and related explanation will be as it is. So this is about half bridge inverter using MOSFET with R load. Next is half bridge inverter using MOSFET or IGBT with RL load. We have studied the circuit and waveforms related to R load. Now it is RL, that is resistor and inductive load. So as far as the circuit diagram is concerned, a small modification is there. In series with R, we have added inductor L. This is acting as a load. Now the waveforms are slightly different. We'll consider different intervals. First interval is T1 to T2. That means time period is from T1 to T2. Look at this diagram. This is the diagram. First diagram is the diagram of output voltage. Second is the diagram of output current. We are talking about interval T1 to T2. That means we are starting from this point. 0 to T1 will be the effect of earlier case that we'll discuss later. So let us assume that the circuit starts working at time T1. So we are talking about interval T1 to T2. During this interval, M1, MOSFET M1 will be switched on. As we discussed earlier, whenever MOSFET is switched on, it is acting as a short circuit. And M2, D1 and D2 will be switched off. This will happen between T1 to T2. So, during T1 to T2, this M1 is short circuited. This voltage V0, I mean the current will start flowing like this, shown by this dotted line. So, the voltage across V0, these are the points at which we are supposed to take the measurement of output voltage across RL. So this voltage V0 will be Vs by 2. So this voltage is Vs by 2, and during T1 to T2 the MOSFET M1 is on, but this is the case of inductive effect. Due to inductive effect, the current increases like this. It is like a ramp signal. Current increases in this fashion with some slope from T1 to T2, because during T1 to T2 MOSFET M1 is on and M2, D1 and D2 are off. So M2 is off, so this lower part is we are not considering this lower portion of the diagram. Next time interval T2 to T3, that means I am talking about this interval T2 to T3. Just now I explained, whenever between T1 to T2 MOSFET M1 was on, so this was the corresponding current for MOSFET M1. Now T2 to T3, we are talking about the inductive effect. During T2 to T3, at T2 MOSFET M1 will be switched off. M2 is already off, so during this interval T2 to T3, both M1 and M2 are off. Listen it carefully. Initially M2 was off, M1 was switched on till T2. At T2 M1 is switched off, M2 is already off. So T2 to T3 is the interval. This is the interval in which both MOSFETs M1 and M2 are off. Both MOSFETs are off, that means they are acting as a open circuit, but there is an effect of inductor. We know that in case of inductor, the storing of energy takes place. So even if the MOSFET is off, both the MOSFETs are off. Initially M1 was on, so this part has stored certain energy. This stored energy will be returned back to the source. I am talking about this lower part. I have drawn a separate diagram for this lower part. And due to the inductor action, which we have discussed in earlier video also, the current will flow, stored energy will flow like this through diode D2, because this is off. This is again off, so I am not talking about this part. So through D2, it will continue to maintain the original direction of current. Original direction of current was like this, from right to left. So direction of current I0 is like this. This will take place from T2 to T3. So as shown in this diagram, T2 to T3, there will be decrease in the value of I0, and at T3, whenever inductor returns all the current back to the source, all the energy back to the source, then at T3, value of I0 becomes 0. Now we discussed that in the earlier interval, diode D2 was conducting. So look at this waveform of ID2. So between T2 to T3, due to the return back of stored energy and conduction of diode D2, this is the corresponding waveform related to ID2. Now, next time interval T3 to T4, we discussed that at T3, inductor has returned entire energy back to the source, so current becomes 0. From T3 to T4, T3 to T4, at T3, the current becomes 0 and this second MOSFET is switched on. So At T3, M2 is switched on. So this is shown by this corresponding waveform. So this is the waveform for IM2. At T3, M2 is switched on. Whenever M2 is switched on, like we discussed in case of R load, the opposite polarity gets developed and the flow of current, I mean this polarity will be in opposite direction. Earlier polarity was like this, plus minus. So next will be in opposite direction, plus minus. So the output voltage becomes negative, that is shown by minus Vs by 2 from the interval T2 to T4. That means for the next interval. Now this will take place up to T4 because the MOSFET M2 will be switched on up to time period T4. That means M2 is on for time period T3 to T4. It is shown by this arrow. At T4, M1 and M2 both are off. It is same as the case of T1 जो हमने already discuss किया है, because at T1 also we discussed that both M1 and M2 are off. So same way in this case, I mean for the time interval T4 to T1, I am talking about this time interval, both M1 and M2 are off and the stored energy will be returned back to the source through diode D1. So this is the equivalent diagram. So these are the corresponding waveforms related to I0. So I0 starts decreasing from T2 to T4. This is the interval T4. Again from T4 onwards, it will start increasing and cycle repeats. We know that this diode D1 conducts from T4 to T1. So this is the corresponding waveform related to ID1. Same way it will be from 0 to T1 that we have already discussed. So this is about the RL load as far as this half bridge inverters are concerned. Now we discussed the operation related to MOSFET. If the question is related to IGBT, same like the earlier case, only this symbol will be changed. Instead of MOSFET, we will be using IGBT. Remaining explanation and waveforms will be as it is. Now, the last part of this session is derivation of RMS output voltage. It is applicable for both R load and RL load. We know that in case of R load, we discussed V0 output voltage is Vs by 2 for the period 0 to T by 2, and it is minus Vs by 2 for the next half period, that is T by 2 to T. This is the generalized formula to calculate RMS output voltage, that is V0 RMS square root of 1 by T integration 0 to T V0 square dt. As I said, this is the generalized formula. Now let us put the values in this formula. So this can be written as under root of 1 by T. See, it is V0 square and there are two intervals. First interval is 0 to T by 2. So I will make one square bracket. First integration 0 to T by 2 and V0 square, that means it becomes Vs square upon 4 plus second interval T by 2 to T. So it is T by 2 to T, again this square, that is Vs square by 4 dt. Everywhere variable is dt. Let us simplify this equation. So this can be written as under root of 1 by T. So I can take this 4 outside of each term. So I will write it 1 by 4T. This 4 is taken common from each term. Similarly, Vs square is also common. So this is also constant as far as this integration is concerned. So I will take Vs square also outside this integration. That means Vs square upon 4 is taken common. So in the first integration, we'll get 0 to T by 2 dt plus second integration T by 2 T dt. Simplified further, it is Vs square upon 4T. So it remains as it is Vs square upon 4T into first integration of dt is T. So it is T limits 0 to T by 2. I will mark one more bracket plus this integration is again T limits T by 2 to T. This can be written as under root of Vs s square upon 4t. This answer यहाँ पे ऐसे लिखता हूं मैं, this answer is t by 2. In place of t, we have to put upper limit minus lower limit is 0. So this becomes t by 2 plus, this becomes t, this I am talking about this term, it becomes t minus t by 2. So this becomes t by 2. So it becomes plus t by 2. So t by 2 plus t by 2 becomes t. So t by 2 plus t by 2 becomes t. So this term and this t gets cancelled. So finally you will get under root of Vs square upon 4. So that is Vs upon 2. This is the equation of RMS output voltage. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.